Hello everyone, welcome to Saraswat's classes. I'm Nirupam and I hope all of you are doing great. So today I'll be discussing about the problems related to the growth theory that are being provided at the end of chapter 1 of the book titled Advanced Macroeconomics, third edition by David Ruma. So I'll be discussing the second problem of this end of the chapter section, which is the problem. So let us see what is problem number 2. So problem number 2, they are saying that let's say there is a variable xt, so whose growth rate is constant at a from time 0 to time t1, and at time t1 the growth rate drops to 0, okay, and then it rises gradually from 0 to a1 during the time period 0 to a during the time period t1 to t2, and remains the same, that is at a thereafter. Okay, so this is the problem which they have stated. So now there are two parts of this problem. So the first part is that we have to sketch the graph okay, so we have to sketch the graph of the growth rate of x as a function of time. That is the first part of the problem. The second part of the problem is that we have to again sketch the graph of log of x of t as a function of time. So these are the two parts of the problem. So we have to draw the graphs, and we all know, before we start, let me tell you that the growth rate of any variable is equal to the derivative of the log of that variable with respect to time. That means x dot t by xt is nothing but d of log of xt by dt. So we will use this relation. We'll use this relation to sketch the graph of log of xt as a function of time. But let us start with first the part A of the problem. So what we know as a part of the problem. So if we look at the part of the problem, let us then draw the graph. Okay. So what we know initially? Initially we know that, so this is the growth rate of x, so it is equal to a when t is over the time period from 0 to t1, it is equal to 0 at t equal to t1, and again it rises over from 0 to a, so it is rising gradually between the time period t1 to t2, and then it remains say at a from time period t, okay, rather than t2. So let us now draw the graph. So the x-axis will be plotting the time, and the y-axis will be plotting the growth rate of x. Okay. So now this is the time period 0, and we know here, as per the problem stated, that from time period 0 to time t1, the growth rate is constantly. That means the curve of the growth rate plotted again as a function of time will be constant at a, at a point constant at a, which is the intercept, so which is the vertical intercept 0a. So this is the vertical intercept 0, so it denotes the growth rate of x, which is constant at a from 0 to t. That means the curve will be on horizontal line parallel to the straight line parallel to the time axis from 0 to t. Okay. Now at time t, the growth rate drops to 0. Okay. So that means it will the point will not lie exactly. So there will be discontinuity at time t as the growth rate is dropping from straight from a to 0 at the same at the single time period, that is t1. Okay. So t1 now. So this is the point where the growth rate is 0 because it's a point on the horizontal axis, and hence the growth rate. So that means it is equal. So hence here what is happening, that y is equal to 0. So hence the growth rate is 0. Now the growth rate starts rising gradually from 0 to a from over the time period t1 or time period t1 t2. So it is now again rising till it becomes a again at time period t2. Okay. So it is now rising. So this part is a rising part of the growth curve plotted as a function of time. From t1 to t2 it rises again from 0 to a, and again it becomes constant thereafter at level a. Okay. So this is what is the first part of the problem. Now the second part of the problem is this, that we have to now plot del of xt as a function of time. Okay. So now we'll be having log of x as a function of t. So now we'll be having log of x of t on the vertical axis and again t on the horizontal axis. So let us see what happens. So we all know that the growth rate of a variable is equal to the derivative of the time log of the variable with respect to time. That means when we are plotting, let's say, log of xt as a function of time, we are basically plotting the derivative. So basically we are plotting the derivative of the log of xt against time, which is nothing but the slope. So we are getting the slope of the log of xt as a function of time t. Okay. So now we will be plotting nothing but the slope of log of xt against time. So what is happening at, as we know, the growth rate is constant over the time period 0 to t1 at a, and again it drops at point t equal to t1 to 0 and starts rising gradually from 0 to a over the time period t1 to t2 and remains at that point, and then remains at that level, that is a after t2. So if you look at the growth rate slope, so this will be nothing but log of x of 0. Okay, so at this point, so right starting from this point, we will be having a constant slope equal to a. So the slope of the line will be constant, which is at a. Okay, so this is till time t1. Now at time t1 it's an inflection point, because here the growth rate, because here the graph will become discontinuous because the slope suddenly falls to 0, drops to 0 right at t1, and again it starts rising gradually. That means it's a point of inflection, and hence there will be a discontinuity, and again it will start rising till it till it again reaches the same slope, that is at point t corresponding to the time period t2, it is again reaching the same slope, that is the slope of the log of xt is again reaching a same slope which is equal to a, and it will remain at that level thereafter. Okay, so this is what we get as a graph of the slope of log of xt as a function of time. Okay, so thank you for this your attention to this part where we are actually plotting the growth rates of a variable against time depending on the values of the growth rates that have been provided, as well as plotting the slope of the log of the variables against time, and we are also seeing how the shape of the graphs actually vary with the definition that has been provided to the growth rates as well as and henceforth to the corresponding logs, and how they can be plotted against as a function of time. So thank you for listening to this lecture, and hope that you have been able to understand how the graphs are being drawn based on the information provided. So thank you once again.